If you are preparing for the AZ-900 or AZ-104 exam, Azure networking can feel like a chaotic list of disconnected services. VNets, subnets, NSGs, private IPs, peering, ExpressRoute, it gets overwhelming fast. We are going to organize all these terms into a single cohesive architectural blueprint. Every architecture starts with the foundation, the Azure Virtual Network or VNet. This is your logically isolated private network deployed inside a specific Azure region. Everything else you build sits inside this boundary. Looking at this blueprint, you define the VNet using CIDR notation. Keep the math rule straight. A smaller number after the slash yields a larger address space. A /16 network holds over 65,000 IP addresses, while a /24 holds just 256. If you match your Azure VNet address space to an existing on-premises network range, like a duplicate 10.0.0.0/16, any future attempt to connect the two networks will fail. Plan your IP ranges so they never overlap. To organize that large /16 space, we divide the VNet into subnets. You carve out dedicated subnets for your web servers, your application logic, and your databases. This provides strict internal boundaries where you apply security controls. Certain Azure services also require their own dedicated space, like the Azure VPN Gateway, which must live inside a specific subnet named Gateway Subnet. Here's a frequent exam trap. If you create a /24 subnet, you generate 256 total IP addresses, but you cannot assign all of them. Azure always reserves 5 IP addresses per subnet. That leaves you with 251 usable IPs. Establishing a clean, non-overlapping VNet divided into correctly sized subnets prevents architectural conflicts before you deploy your first virtual machine. With the structure built, we need security checkpoints at the doors. These are network security groups or NSGs. If you place an NSG on a subnet and a second NSG directly on a virtual machine's network interface, a data packet must successfully pass the rules of both checkpoints. If either NSG blocks the traffic, the connection fails. NSG rules are evaluated based on their priority number. Don't fall for the intuitive trap that a bigger number means more power. In Azure, a lower number has a higher priority. A rule at priority 200 is processed before a rule at priority 300. If 200 allows the traffic and 300 denies it, the allow rule wins. This animation shows how internal communication works. Virtual machines use private IPs to talk inside the VNet. However, for modern Azure deployments, a new subnet with only private IPs is blocked from the internet by default. A virtual machine cannot browse the web unless you explicitly configure an outbound method like attaching a NAT gateway to the subnet. When you have multiple VNets across different regions or departments, they are completely isolated by default. To connect them, you use VNet Peering. This links two Azure networks together over Microsoft's private backbone, allowing resources to communicate securely. Pay close attention to the routing logic here. VNet peering is non-transitive. If VNet A is peered to VNet B and VNet B is peered to VNet C, VNet A cannot automatically communicate with VNet C. You must explicitly peer A to C. This strict behavior forces you to design intentional secure routing paths rather than accidentally exposing environments to one another. To connect your physical office to Azure, you evaluate scale and pathways. A site-to-site VPN connects an entire corporate network over an encrypted public internet tunnel. A point-to-site VPN connects a single individual laptop to the VNet. For enterprise workloads requiring high speed and predictable performance, ExpressRoute provides a dedicated private fiber connection that bypasses the public internet entirely. Once connected, resources need to find each other by name. Public DNS acts as a global directory for internet-facing services. Private DNS is a restricted internal directory. It only resolves names for resources inside the specific VNets you explicitly link to the zone. Let's cement these foundational scenarios. Isolation requires a VNet. Segmentation requires a subnet. Filtering requires an NSG. In a conflict, 200 beats 300. VNet to VNet connectivity requires peering. Linking an office requires a VPN. And enterprise reliability requires ExpressRoute. Private pass access requires a private endpoint. Looking at this diagram, we see an Azure storage account with its default public endpoint. To keep traffic off the internet, we deploy a private endpoint. This creates an underground tunnel, giving the storage account a private IP address directly inside your VNet. Your applications can now reach the service securely without traversing public routes. Creating that private endpoint does not automatically disable the public entry point. If your security mandate requires the service to be strictly private, you must configure the service to deny public network access. Establishing private connectivity and blocking public access are two distinct configuration steps. We've built the entire architecture. Now test your recall. Pause the video and see if you can name the service used to connect two VNets versus connecting a remote laptop to Azure. Let's map the scenarios. Need an isolated network? Virtual network. Need to divide that network into tiers? Subnets. Need to filter traffic at the door? NSG. If NSG rule 200 allows traffic and rule 300 denies it, 200 wins. Lower number equals higher priority. Need to connect two VNets. VNet peering. Can A talk to C through B? No. VNet peering is non-transitive. Connecting a single laptop? Point to site VPN. An entire office over the internet? Site to site VPN. A large enterprise needing a private connection? ExpressRoute. Internal name resolution? Private DNS. Securing a PaaS database inside your network? Private endpoint. And if a new private VM needs to browse the web, check your outbound rules. You need a NAT gateway. For your exam, map the business problem to the architectural boundary. Ask yourself, am I trying to create a network, subdivide it, secure it, or connect it to the outside world? The requirement determines the tool. Azure Networking is a single interconnected system. Once you understand how these components layer on top of each other, you no longer have to memorize isolated services. Identifying the specific problem automatically reveals the correct architectural solution.